I don't care. All right, so yesterday, listen, we did I think we're working on the evens. All right, so what I want to do is, if you're having an issue, I don't mind going over a couple of these, but today we have something else we need to get busy on. All right, so does anybody have any questions with yesterday? Anybody have any questions with yesterday? Good. Yeah, let's talk about those. All right. Now, again, we're going to handle those a little bit different, but today specifically, which one did you want me to look at? 27 and 29?
Yeah.
Let's do that. Let's look at 27 and 29 real quick. And then
wait, what am I supposed to do?
yeah, but he asked me about the odds. It doesn't really matter. All right, because I'm going to tell you we're going to finish this up tomorrow, I think. All right. Okay, now, again, here we go. Now I'm ready. All right, for question number 27. All right, so please look up. It's Bragdon. I don't want you, I want you to concentrate for 40 minutes. That's what you're doing. Now, here, it's not set up as a substitution because it's not in the form y equals or x equals. So we have to put it in that format. So what I need you to think about is this negative 6x has to go on to the other side. If I move it to the other side, it's going to become a what? Positive 6x. All right? So now this over here, this equation is going to change to y equals 6x plus 20. Does that make sense to you? Right? Now it's in the right format where it's y equals something. So now what am I going to do? I'm going to take this y equals right here, and I'm going to plug it in for this y right over here. You see that? Now watch what happens. Negative 3x minus 3 parentheses 6x plus 20 equals negative 18. All right. Now, from there, we're going to distribute the negative 3. All right, negative 3x minus 18x minus 60 equals negative 18. And now that I have that, I'm going to combine like terms. These two are going to combine. So we have negative 21x minus 60 equals negative 18. Now I'm going to add 60 to both sides. So I'm going to have negative 21x is equal to 42. So x is equal to negative 2. Now remember, now that x is negative 2, I'm going to put negative 2 right into this equation right here. So I have y is equal to 6 times negative 2 plus 20. Y equals negative 12 plus 20. So y is equal to 8. So my answer is negative 2 comma 8. Yeah, just stop talking. All right? All we're doing is listening.
Yes, sir. It's like you have multiple x and multiple y. Like I had a question on like number
Come on, it's just
like number 38.
all right. I'm not sure why you went all the way to 38, but
No,
I appreciate it though. I do appreciate it. So let me find 38, and I'll talk to you about 38. All right. Now, part of the reason why I didn't assign this problem is because it's hard to put it in a substitution format. You know what I mean? After today, you'll know how to solve that. All right. It's just a different technique. All right. There's a different technique. That's why, if you notice, I just assigned 1 through 30. All right. I just assigned 1 through 30. Yeah, I'm agreeing. Okay. Now, we're going to spend some time tomorrow kind of putting everything together. All right, so I want you to concentrate right now. I want you to load up 6.3. All right, I want you to load up 6.3. Now, what we did is, I'm just going to erase this real quick. All right, with the 7th grade algebra class, here's the problems I did. 1, 2, 7, 8, 11, 12, 21, 22, 27, and 28. Okay, so I'm going to try to avoid those problems, and I'm going to try to give you an opportunity, if you're struggling, the explanation for those are already on the book. You with me, or on the video? All right, so listen, all the silly things that are going on, all right, we're wiping that out. All right, that's part of my issue. Some of you guys think you're trying to do good, all right, but you're thinking about something else. Giving me 75%. Listen the whole time. All right, stop playing around. Focus up here. All right, that's why I don't want you guys sitting next to each other. All right, I'm on 1 and 2. I already did 1 and 2 with the other class. So what we're going to do is I'm going to show you how to do 3 and 4. Now, again, up here, addition and elimination. What do you think today, instead of substitution, we're probably going to do what? You're going to add them. All right, that's probably what we're doing. We're going to add. So I want everybody to go ahead and grab questions 3 and 4. Tonight you can do 1 and 2. All right. Grab 3 and 4, and let's bring it down to the bottom. And let me show you how really, really simple this is. All right, here we go. Now again, why do you think they call it addition? Because you can just add them. All right. Now, the objective when you're solving a system of equation is to eliminate a variable. All right. Yesterday we did it by substitution, where y equals something or x equals something, and then you just substitute it in. Today I want to show you we're just adding. So all you do is you draw your line underneath it. Now, what do you think you're going to do to those? Add them. What happens when you add these right here? Yes, they cancel. Look how simple that is. But you can't know how simple it is unless you're paying attention. I'm adding them. Now, when I add them, what happens to 5y and negative 5y? Wow, they cancel also. So after all that, that just becomes 0 equals negative 9. Does 0 equal negative 9?
No.
No. So this is no solution. It's no solution. Now, what does no solution mean in the context of graphing lines? It means if I graph that line and I graph that line, how many times are they going to intersect? Never, because they are what? They are parallel lines. Listen to me now. Those are parallel lines. So when you create a false statement, 0 equals negative 9, that's telling you that they don't intersect, that they are parallel. Anybody have any questions with that? What?
Can a line ever intersect like more than once?
Okay, so that's actually a very, very good question. All right. So what makes a line a line?
It like always is.
We say the slope is the same. That's what they mean when they say straight. The slope is the same. So if I were to draw another line, is it possible that the line does something like that so it crosses at 2 spots? No, it's not possible. That's why that's actually a very good question. Your line has one of 3 things. It can intersect at what? 1 spot, it doesn't intersect, or watch, I'm going to do this. I can graph these two lines. If I graph those two lines, we say that there's an infinite number of solutions, because when you graph the same line, you're graphing it on top of it, so there's an infinite number of solutions. You with me? So that was actually a very good question. So all lines, that's why when somebody says to me, draw a straight line, we say that is redundant. Why is a straight line redundant? Because a line is what? It's always straight. All right? You don't have to say straight line, because if it's not straight, it's not a what? It's not a line. All right? If you go further in math, listen, if you go further in math, eventually someone will tell you there is no such thing as a straight line. All right? Why is there no such thing as a straight line? Is it possible for me to walk in a straight line? No. Why is it not possible? Because we're on a what?
Axis.
We're on a ball. We're on
Flat Earth
something that's
society.
round. We're on something that's round. All right, so if you're on something that's round, it's really not possible to draw something straight. All right, but that's when you get to higher level math. It's really, really fascinating. All right, upper level math where you're kind of thinking outside the box a little bit, it's kind of strange. All right, but let's get back to question number 4 now. All right, so question number 4, let's take a look at this. Now, when I add these, all right, what happens now? Wow, now I get 0 equals what? 0. Julia, listen to me. I am not sure what you're doing. I'm trying to be nice. I'm trying to tell you girls, stop playing around and focus. That's the issue. My problem is trying to help you get better at math, and some of you just don't want to. All right? So either I'm nice or I can be mean. Now, I just talked to you about 0 equals 0. What does 0 equals 0 mean? It means that the lines are what? No, the lines are the same. All right? If you get a true statement and both variables cancel out, that means you're graphing the same exact line. You're graphing the same line. And if you graph the same line, that means there is an infinite number of solutions. We say there's an infinite number of solutions.
What does that mean?
That means, look, that point right there, is that a solution?
Yeah.
Is that a solution? Is that a solution? Is that, you see what I'm saying, right? There's an infinite number of solutions,
So
because
anything,
that's exactly right. Not all real numbers. That doesn't say all real numbers. That says there is an infinite number of solutions. Because if you were to graph one line on top of the same exact line, they always intersect. Do you understand what I'm saying? That's why I try to draw it up here as the highlighted line and the red line. They always intersect. There's an infinite number of solutions. All right? If they are parallel, do they ever intersect? No, that's why it's no solution. Your other choice is one solution. What?
So, if the answer was like 1 equals 1, would it just be kind of the same?
That's a true statement.
Or like 2 equals 2.
That's a true statement. That's exactly correct. If the variables cancel out and it creates a true statement, it's infinite, or it's the same line. Right? If you create a false statement, that means they're parallel lines. No solution. Good. All right. Now what I want to do is, I really didn't mean to start out with the two tricky ones, but let's go grab 5 and 6 now. All right. Let's grab 5 and 6. All right, here we go. Let's look at 5. 5 is kind of what? The same thing. All right, so let's look at 5. That's my mistake. But still, if I add them, what's happening? They cancel out. This cancels, so we get 0 equals -6. So because you were listening, now you know that that's a false statement. So that means the lines are what?
Parallel.
They are parallel. Thank you for listening. The lines are parallel. If the lines are parallel, that means there is what? There is no solution. All right, there is no solution. All right, so now finally, a good problem here. So please look at question number 6. All right, I want everybody to look at that. Tell me why that one's super easy.
I'm just adding it. It's just 10. It's just.
Well, wait a minute. No, look better. Look up. Come on. Read the top one.
5x minus 5
Equals what?
negative 15.
One. Yes. I know some of you guys are writing things on your iPad, but when I say look up, I know it's hilarious now because I'm being mocked unmercifully here, all right, about saying look up. The reason I'm saying look up is because I'm trying to show you something. If you're not looking up, you're not going to understand what I'm saying. It doesn't matter what's being written on your iPad. I promise you, this is a ridiculous problem. It shouldn't even be on here. All right, but I think it's on here because they're trying to just demonstrate if you pay attention, it's just this easy. I want everybody to read the top equation. Say it out loud. Go.
5x minus 5y equals -15.
Okay, now I'm going to ask you something really dumb. Read the second equation.
5x minus 5y equals -15.
So, what is true about those two equations?
They're the same.
They're the same. Didn't we have a discussion about things that are the same? So how many solutions are there? Hold up. How many solutions? Infinite number of solutions. It's an infinite number of solutions because it's the same what? It's the same exact line. Same exact line. Infinite number of solutions. Do I have to do anything there? Is there anything to do? No. Other than to just be looking at it and saying, wow, that's kind of silly. It's the same equation. If it's the same equation, then there's an infinite number of solutions. All right? That's all I'm asking. I don't have to do anything. I just have to write same line, infinite number of solutions. Anybody have any issues with that? Now, do you understand what I'm trying to also tell you is if there's parallel lines, how many solutions do parallel lines have? None. Thank you. None. Exactly right. They have no solution because parallel lines don't intersect. If you have the same line, they're graphed on top of each other, which means there's an infinite number of solutions. All other lines are going to intersect how many times? Once. Thank you for listening. No solution if they're parallel, infinite solution if it's the same, and one solution for everything else. All right? Now, for question number 6, everybody should just write down, silly problem, same line, infinite number of solutions. There's no work involved. There's no work because we paid attention. All right? Now, let's try something else now. Let me look at 7 and 8. Actually, I'm going to have to grab 1 and 2 again. Sorry, we're going to have to go backwards. All right? Let's try 1 and 2 now. All right, here we go. Now we're going to add. And look what happens when I add them. What happens to 4x and -4x this time? They do what? They cancel, but does the y cancel? No. So look here. These guys cancel. What's 2y minus 9y? -7y. Good. So what? -7y is equal to what?
-2.
To -28. Right? You're good. It doesn't matter. I know what you mean. Now, divide by -7. We divide by -7. Y is equal to what? y equals 4. Now, all right, something that I really should have started with, but I didn't realize the others were that way. Is everybody okay with y equals 4? Any questions with y equals 4? Now I have to figure out what x is, right? So now we go and we sub in for y. What? 4. So here we go. 4x plus 2 times 4 equals 0. 4x plus 8 equals 0. 4x equals negative 8, so x equals what? Negative 2. All right? So the solution is what? The solution is negative 2, comma 4. Now, what does that mean? That means if I were to graph those two lines, they would intersect at what point? Negative 2, comma 4. Now, your job, if you're trying to be a good student, you're trying to listen, is to ask me now. If you're not understanding where I got the negative 2 or the 4, now I need some help. All right, I can't help you if you're not going to ask. You're not going to participate. All right, everybody okay with that? Come on, if you have a question, Julia, trust me, I want to help you. I just get frustrated when you're not paying attention. And then you don't understand something because you didn't pay attention. That's my frustration. Come on, I promise you, it's super simple. It's really, really simple. All right? Now, we're going to do the same thing with number 2. We're going to go ahead, and because it's addition, we're just going to add it. All right, I want everybody to add the first step. And what's the answer, Carly, when I add the first step?
When you add negative 7x and negative 9x, the answer is negative 16.
And what happens to the y's?
It cancels out.
And then?
And then it equals negative 32.
Now, do you understand? That's not that hard now. Come on. Just adding it straight down. Because you recognize the x's. I know. We know what you meant. And now after I do that, I divide by negative 16. So everybody should be able to tell me quickly that x equals what? X equals 2. X equals 2. Any questions with that? Now, I take 2 and I plug it in for x. So is everybody okay with me saying 2 times negative 7 is what? So I don't have to write that step in. You should know that. So now I write negative 14 plus y equals negative 10. Will, are you with me? And now I add 14. So y equals what? Y equals 4. Y equals 4. You with me, Julia, or not? Say that again. Very good. So watch. What does x equal? 2. What does this say right here? What does that mean? Not O. Doesn't mean O. What does that mean? There you go, kiddo. Now look, this is what I'm trying to tell you also. Listen to me. Hey, you're not listening. What I'm trying to tell everybody about math is it's just logical. So here's what I'm trying to tell you. I said x equals 2, and then I put negative 14. I want you to be able to say, well, how did I get 14 from 7 and 2? What do you have to do? I want you to learn how to make that observation. That you might be wrong, but I'm trying to show you just the logic behind it. That there's only one way I can get 14 with 7 and 2, and that would be multiply. You understand what I'm trying to tell you? I want you to come up with that conclusion. That's why I get frustrated with some of you. I can stand up here all day, and you can copy all the notes off the board, and does it ever affect the outcome that you're going to get? Never. It's not. You know why? Because all you're doing is copying things down. And I'm trying to tell you, stop copying things down. I want you to do the thinking, not me. All right? So now the solution here is what? What's the solution? 2, 4. That's the answer. 2, 4. Are you with me? All right. So write 2, 4. All right? Now what I want to do is I'm going to come up here and I'm going to grab a couple more. All right? Now, these are a little bit more challenging. So if you're not paying attention, we're going to have some problems.
Wait, for the last one, how come we didn't use the bottom one?
You can use the bottom one. You can use whichever one you want. You hear me? All right. All right, here we go. We'll try 7 now. Okay. Now these are almost the same, right?
Yeah.
4x minus 6y and 4x minus 6y. Look up, come on. Come on, I'm trying to say something. I'm trying to make you smarter. Is it possible for 4x minus 6y to be negative 10 and for 4x minus 6y to be negative 14? No, that's not possible. So it's what? That's what you're supposed to be able to see. Right? We don't need to do math on that. That's the difference between someone doing math and understanding math. That's dumb. 4x minus 6y can't equal negative 10, and 4x minus 6y can't equal negative 14. That's not possible. So what can you tell me about those two lines? Those two lines are probably what? Think back to what I said earlier. Nope. They're parallel. The reason why it's parallel and not the same, hello, right? They have to be parallel because there's no solution. It's not possible. That's what I'm trying to tell you. If it was the same line, it would be 4x minus 6y equals negative 14, and 4x minus 6y equals negative 14. Is everybody with me on that? You see that? So this is what? I want everybody to write down, obviously, no solution. And then underneath that, I'm trying to make sure you're hearing me. No solution means the lines are what? Parallel. The lines are parallel. All right, come on now. I'm feeling kind of pretty good. All right. So now, here is an issue. Number 8. Put a star by number 8. Fantastic problem. All right. Today's lesson is to do what? Add them. Do you agree? Well, if I add them, does anything cancel?
No.
No. So this is called a medium problem. The ones we did earlier were easy. These are now medium. The reason why they're medium is because I can't just add them and get them to cancel. Julia, what do I need this negative 3x to be in order for it to cancel out? Oh, thank you. Wow. I don't want it to be negative. I want it to be a what? Positive 3. Because if it's positive 3 and negative 3, what's going to happen? It'll cancel out. So am I allowed to just make it negative? Yes, you're allowed to just make it negative if you multiply the entire equation by negative 1. Now, somebody in my last class said, well, why are you allowed to do that? That doesn't make any sense. So let me show you why that makes sense. Everybody look up so I can make a demonstration. Does 2 plus 3 equal 5? If I multiply the whole thing by negative 1, negative 2 minus 3 equals negative, is it still a true statement?
Yes.
Is that still true?
Yes.
Yes, it is true. Okay, so that is why you can multiply by negative 1. Is it the same exact equation? No. Is it still a true statement? Yes, it's still true. So if you multiply an equation all the way through and it's true, you create another what? True statement. All right? So I'm going to multiply the top equation by negative 1. And when I multiply the top equation by negative 1, here's what I get. I get 3x minus 3y equals 12. Jesse, does that make sense? Allison, you still with me? Kate? Now, am I going to add these together? Yes, because what happens when I add them together? They cancel out. The negative 3x and the positive 3x do what to each other? Cancel out. So what's 9y minus 3y? 9y minus 3y today is 6y. 6y equals what? Negative 12. Thank you. Come on, we need help. 6y equals negative 12. So y equals what? Negative 2. Now, Kate, if I'm not saying something you understand, you got to ask. Do you understand that? Allison, you with me on this? Emily, you still good? All right, so now this means wherever I see a y, I can put what?
-2.
So I'm showing you, I'm going to put -2 right in there. And Julia, what am I doing with that? Thank you very much. All right, so now I have -3x minus 6 equals -12. -3x equals -6. Uh-oh. Did I make a mistake? Shh, hold up, I'm asking.
Crossed out -3. It's supposed to be positive, isn't it?
Do you see what I'm looking at right up here, Colin? You make a good point, Colin, so listen to me now. I'm plugging it into this equation right here. I could plug it into the bottom equation. Do you agree?
Oh, I see.
You see what I mean? Does it matter which one I plug it into, Colin?
No.
No. You'll always get the same answer. Are you hearing me, Julia? It doesn't matter which one I plug it into. You're going to get the same answer. All right? So now, if I continue, Colin, are you with me now?
Yes.
X equals 2. So my solution is what? 2 comma -2. 2 comma -2, right? Come on, I don't think it's that hard. I don't think it's that hard. All right? I'm listening. Any questions? Nobody? All right, so let me grab another one. Let's try to make it harder. Okay, I'm going to grab 9. We're going to do 9. Try to stay organized. Okay. What do I have to do, Will?
You make it what? -x minus x.
Do they cancel?
Yeah. Or no, they don't.
So I have
You
to
have to put it.
multiply by,
-1.
exactly, multiply the top equation by -1. Multiply the top equation by -1. Okay, does that make sense? Alex? Now if I multiply the top by -1, now I get x plus 5y equals -28. Everybody good with this? And now, what happens to the x's? They now can cancel. Those cancel. Now when I add the y's, I get what? 9y equals -45. And so now y equals what? Y equals -5. Y equals -5. Now, Colin, does it matter which one I plug it into?
No.
No. Plugging it in here. -x. Now when I plug it in, it becomes -x what?
-25.
No. Why is it plus 25?
Oh, because you're multiplying
A.
negative times a negative.
That is exactly correct. You're multiplying a negative times a negative. All right, that's the common mistake. So it would be plus 25 equals 28. -x equals 3. So x equals -3. Now, I'm trying to also demonstrate how much quicker I'm doing these equations down here because I feel like you should be good at that. Now, if you're looking at me going, man, I don't know how you're getting that -3, now's your time to speak up and say, come on, slow down a little bit, help me out a little bit. You okay with this? So my answer now is what?
-3 comma -5.
Because we always write xy. We always write xy.
So couldn't you
Good,
use
good. Come on.
X plus 5y equals -20 to fill in? Because you can put -5 into.
You can do the second one or the third one. Yes. All right, either one. All right, now I'm going to make it a little bit harder on you, so I need you to concentrate. So here we go. I'm going to grab number 11 now. Grabbing number 11. Pulling it down. Thank you so much, man. I don't know where I'd be without you. All right. Now look at number 11. Look at number 11. Someone who's been kind of following along with me. All right, Vivian, here's your time to shine. What do I have to do?
Okay, so
Shh. Come on, you guys should be thinking about it too. What should I be doing?
the number cancel.
So what do I have to do?
Number is the same.
So what do I have to do? Ben, tell him. What do I have to do, Ben? Shh. Carly, jump in. Yeah, if you want to jump in, jump right on in, Carly. There's no reason to talk to her. Jump right in here and tell me what to do. I'm interested because you know what? You're smart enough to tell me what to do, but you're just afraid to be wrong. So you're not going to tell me. So what should you do? Good for you. Give it a shot. What am I going to do? Wow, wow, wow. That's pretty good. So what do I want this number right here to be? What do I want it to be?
2y.
2y, or do I want it to be negative 2y?
Negative 2y.
Why do I want it to be negative 2y?
So it'll cancel out.
So it will cancel out. So right now it's negative 1. I want it to be negative 2. What do you think I do?
Multiply everything by 2.
Multiply everything by 2. That's not that hard. Now, why am I multiplying everything by 2 again?
Because you want it to be 2y.
I want them to cancel out. So I'm going to multiply the top equation by 2. Come on, that's how simple it is. One has to be positive, one has to be negative. They have to both be the same number. When you add them, they cancel. All right, so now I'm going to show you something. Multiply the top equation by 2. Multiply the top equation by 2. Come on. When I multiply the top equation by 2, I get 4x minus 2y equals 10. Right? Now, you should be looking at that going, well, that kind of makes sense now because what's going to happen if I add them now? Now they cancel. Before they would not cancel because when you add them, they wouldn't be 0. So your job is to make the x and the y exactly the same, one positive and one negative. Now when I add them, I get what? 9x equals negative 18. Because what happened to the y's? They canceled. So x equals what? X equals negative 2. Now that I have x equals negative 2, I'm just going to do what? Plug it in to figure out what y is. And when I plug it in, I get what?
Negative 8 minus 2y.
Okay, so I'm plugging into the top one. So let's just do me a favor. Plug it into the top one.
2x plus 2y.
Come on now, Miss Bragdon. Look right here, kiddo. This is a negative 2. I'm plugging negative 2 in for that x. What does that become?
Oh, negative.
Not x. Not x. Just negative 4. True? Just negative 4. Jesse, are you looking at me like I'm crazy or you know what you're doing? No, I know you're listening, but are you understanding? All right, come on. I saw that crazy look in your eye. Negative 4 minus y equals 5. So now I move the negative 4. So negative y equals 9. So y had to be what?
9.
Y has to be negative 9. Thank you. So my answer is
Negative 2.
negative 2, negative 9. Ben, am I good? Right? You good? Happy with that so far? All right, I'm going to, one more hard problem. All right, here we go. Last one that's tough. This is as hard as I can possibly make it. So here we go. I'm going to do 21. So grab 21. Man, long time to go to the restroom. Okay, why do I have problems? Why do I have problems?
Because none cancel out.
None of them are going to cancel out. Ooh, good. Made it back in time. Let's go. Come on, I'm on the hardest one I can do. 21. We got a problem Ben, what's my problem here? There's no way to cancel them out. Anybody want to give it a shot? What do I have to do? Good for you. What?
Do you just like subtract?
Come on, don't have to tell me what. Just tell me what to do. And you know what? I might say, "Wow, that's great," or I might say, "That's wrong." It doesn't matter. Come on, that's what it is. Think about it. What am I doing?
You just subtract 6 from 6x.
No! We want them to be the same. One positive, one negative, and want them to cancel out. It's the same process. This is harder because I can't just multiply something. What do I do?
I was gonna multiply.
That's nothing. That's no contribution to the class.
I was gonna multiply, but
What are you going to multiply by?
I was gonna multiply the top by -5. So then it would.
And the bottom by?
Oh, the bottom by. I wasn't gonna multiply.
Well, okay, so you multiply the top by -5. Now, which
Oh
one
wait,
of them
and
is the
multiply
same?
the bottom by.
What are you talking about? Yes. All right, so try to listen to what he said. So, easy. The easy problems are if it's the same number, opposite signs. Medium problems are when you have to just multiply one equation. Hard is when you have to look at it and you go, wow, I can't multiply the top by a number, and I can't multiply the bottom by a number, so I'm probably going to have to multiply both equations. All right, so when I multiply both equations, come on, girls. He said perfectly, I'm going to multiply the top by -5 and the bottom by 3. Now, why did I multiply the top by -5? Because that's going to create this number right here, +15, and this number down here will be what? -15, and then they will do what to each other? Cancel. Now, the next brilliant thing is, well, what if I could multiply the top one by what?
Oh, do the x one?
Yeah, I could multiply the top
so
by 6 and
then
the bottom by
-7.
-7, and that will eliminate the x's. Come on, stay with me, girls. The lunch room's not going anywhere. All right, I promise you. Lunchroom's not going anywhere. All right? Wherever you guys sit, that's going to be the cool place. So you have nothing to worry about. No, look up. So this right here is going to be 35x. Just give me one more second. Well, 5. 35x plus 15y equals -60. And then -18x minus 15y equals 60. Now do you understand? They do what to each other? Cancel out. Now, last thing I want to tell you, sorry, is look, we're going to finish up tomorrow. All right, listen to what I'm saying, guys. Tomorrow's Halloween. I'm not going to give you a bunch of work,
Yes.
but I haven't really checked your homework, so we're going to make sure that you know graphing, substitution, and elimination tomorrow. Try to do the odds or try to do the evens tonight. That's what your job is. Why are you guys running? Why do they sprint to the...
Because the table and they want us to do.
Do we have a quiz starting?
I need to go find out what's so popular.